So the goals for today. First, I want to make sure you guys kind of get a chance to learn some things, gain more confidence in kind of the understanding of the industry and specific topics and technology and things like that. And second, be able to feel more confident in speaking that to other people. So whether you're in manufacturing or you're supporting manufacturing, being able to walk through a shop floor and actually have a conversation with someone and not to necessarily, you're not going to be an expert coming out of the meeting of the program today, but at least being able to understand some of that language and speak it a little easier and more comfortably, so you just have that confidence. Tongue in cheek here, say don't be this guy. I had a meeting a few years ago with one of our key long-term sponsors, a banker I'd known for years, great guy, but he went to every meeting, every event with a pinstripe suit, hair slicked back, I mean, good-looking guy, he dressed well and everything, but he just looked like a banker. No offense to bankers, but you know your goal is to connect with people, right? Connect with the industry you're working with. So this guy walking through the shop, you can tell it's probably AI generated and all that, but he's wearing his suit and wearing the hard hat, which you walk through most manufacturers, they don't wear hard hats. So you can always tell AI generated or stock photos and stuff like that. So this guy looks like he plays the part, but he's not really a manufacturing guy. So rules for this discussion. Again, if you were here for the first session, I kind of dumb things down for you. So some of you may have some experience and knowledge on certain things beyond what we're covering. So I apologize if I'm insulting you by talking about things at basic level, but we're going to assume for the sake of this conversation that you don't know any of this stuff. So I'm going to kind of play it simple and please don't be offended. There's no dumb questions. So this is meant to be interactive, so feel free to raise your hand anytime to ask a question, anything I'm covering. I'll do my best to give you the answer or make it up as best I can on the spot. And feel free to ask lots of questions. Share things you do know about. So if I'm covering something and you've got some experience with it, feel free to raise your hand and share something you know about that subject. And beyond today too. Again, we're all learning stuff, we all learn stuff, right? So if you've got things that you know about, don't assume everyone else knows it. It's good to share with other people in your business as well. And there are no perfect answers. I say this because we all in industry even feel like we're supposed to know certain things, and then you go talk to somebody you think is an expert, and you're going to hear things from me today that someone else might say they disagree with. There's no exact right answer. Some things are a little bit more subjective. Obviously, some things that are very factual, but there's a lot of things that are kind of people have different opinions on. So I'm going to give you what I think makes sense on behalf of the industry, but it's not going to be perfect answers. So topic one, repeat utilization, synchronization of equipment. Anyone heard that before? It's a great tool for finance and accounting. I know we got a lot of people that are in the finance and accounting area in this room today, so it just helps for a better understanding of equipment utilization. Which leads me to rule number 6, for those of you who heard for 101. Be careful who you trust with your questions and the answers. Repeat utilization, synchronization of equipment is indeed a ruse. So I like to throw something in there just to kind of make you question what you're hearing from different people and the answers you get. So that is nothing real, it's just a made up thing. I don't know. So you can ignore that. Wipe it out of your brain now. So the topics we're going to cover, well actually the topics we did cover in 101, for those of you who weren't there, we talked about some general industry, just basic information on machining, other processes, and then some government and education related things. So, but today, we're going to talk about some other shop talk, just some other vernacular from the industry and then in the shop, equipment and materials, quality, and lean. So those are a few topics today. Again, there are tons of things we could cover. Well, I should use this clicker now. But those are the things we're going to cover today, and I'll dive into them for reasonable amounts and learn some bits and pieces of each of those. All right, so starting with another shop talk, I'm going to go through kind of some of the main systems and software. You guys have probably heard some of these terms. For sure, some of you already use some of these systems, so you may be already familiar. But we're going to talk about ERP systems, MRP, CRM, QMS, LMS. You guys, some of you recognize some of those, right? So again, we'll go through kind of that basic level. So we'll leave ERP for last. MRP, Material Resource Planning. So this really covers the production processes. So this dives into the shop activity. So planning how things are going to route through the shop, what raw materials we need, how many parts we already have, or how many parts we're going to make, managing the inventory itself. So it's kind of the things that are going through the shop. Just another bonus word that you may already be familiar with, bill of materials. So when we talk about what it's going to take to make something, a bill of materials is a term we use in manufacturing a lot for what's going to go into that product. So what type of raw material we're going to use, how many of different components are going to go into it, the packaging. So just a term you might want to know. CRM, I'm sure most of you probably know that, right? Or at least you know, or you'll recognize it, and you probably do use a CRM system, but customer relationship management. So, I like one of our sales guys in the industry. But it's basically the whole sales cycle, right? So it's from marketing to outreach, it's your marketing campaigns, your email campaigns, things like that. Contact tracking, so when you make those sales calls, tracking the sales calls, tracking the, I called Bob at ABC Paper Company, and he's got 3 kids, and keeping track of that stuff. So the CRM is really just tracking your sales activities. You guys are probably familiar with like Salesforce. HubSpot is actually what MPMA uses, which is another big platform. QMS, you know what that stands for? Quality Management System. So that can be anywhere from daily tracking of your daily quality activities, your in-process inspections. We'll talk about quality in a little bit, but your day-to-day activities on the shop floor in your inspection lab, all the way to your whole system, your quality system, your official policies and procedures, and then your regulatory controls through whether ISO or FDA or ITAR and things like that, whether it's med device, aerospace, defense, things like that. So really your quality management system is everything about how you control your product and your processes within your company. LMS, you may not have heard of that. A lot of companies do have an LMS system, just maybe not as familiar of a term, but it's a learning management system. So basically just tracking all your internal training and usually online tracking. So the training may be in person or live, it may be online training, but basically it's it allows you to be able to track every employee and where they're at in their stage of training, whether they're A level, B level, C level at a certain position, or they've received their safety training, or their specific technical training, things like that. So a lot of companies now are using, especially companies that are growing in size, rather than trying to track everything on an Excel spreadsheet, they're using more of a software that'll help, especially with a lot of people working from home, or people that can just do their training at a computer on break or at a computer at home, and being able to track all that online. And then the ERP, I let's say this for last because really ERP is kind of the composite of all of those. So enterprise resource planning, ERP, is really all the business processes into one. So this circle chart here, it shows kind of all the different aspects of the business, from your quoting and your sales force activities, to running a project through project management, materials purchasing, invoicing, the actual production process, everything in between. So ERP is really the whole system. But some companies choose to have one ERP software that oversees all of their processes. Some people might have different softwares for their material planning or for their QMS or other areas. So could it be all in one, or it could be a number of different systems. And some of the examples of that: NetSuite, Epicor, SAP, Sage, those names you guys are probably pretty familiar with. Another general term for manufacturing, you guys have probably heard, it seems pretty common sense, but lead time is really just the time from purchase order to delivery. So obviously manufacturers talk about that a lot, and how long it's going to take. A lot of people get wrapped up in thinking, well, it takes X amount of time to build a product, but in reality, the lead time can be 10 times that, right? Because especially in the last few years, supply chain, you guys have heard, has become such a big challenge. So it may take you 2 minutes to build a product, but it took you 10 weeks to get the component that goes into that product, right? So really lead time is that whole process from purchase order to delivery, whereas then cycle time, you may or may not be as familiar with that term. We use that in manufacturing all day, every day. It's the time that it takes to make one part or one set of parts. You might have a mold that makes 64 parts in one shot, but that cycle time is that cycle from the time that you start a process to the time you finish a process, and whether that's running a machining center or running a molding press or a stamping press or whatever, just the time it takes to make that one set of parts. So overall, again, like I said, that cycle time is a portion of that whole entire work lead time. Again, it could be 40% of the lead time, it could be 1% of the lead time, and that is differentiated a lot between companies that are like more make-to-order, custom contract manufacturing versus ones that are off the shelf, right? So if somebody does standard product, they've got their own product line, they might make something within a day or two of getting a purchase order, whereas someone else 6 months to get something produced. Work cells. Sounds pretty common sense, but again, these are some terms we use in manufacturing a lot. So just in general, a work cell, when you hear someone talking about that, it's just an area in which a work or product is produced. So, and that could be an assembly station, it could be a machining center. So this machining center she's standing at, she might have one machine she's working on in a work cell. She might have 3 machines she manages, and then it could be an automation cell too, where nobody's working in this cell. But it's basically just an area or a group of machines in an area that that's producing that product. So that's that, any area that work's being done we call the work cell. All right, now I'm going to move into equipment. Any questions on some? I know this was just kind of a spattering of a few different things there, but just again some different terminology used in the shop and the industry. But any questions? Anything I covered so far? All right, so I'm going to move into equipment and materials. So I'm going to define, we're into the slideshow ways, I'll define what I would call as manufacturing, and I do this to be able to explain why, where kind of materials fit into that. But, and we have this conversation all the time, especially with students, young people, as define manufacturing, right? And most elementary or middle, high school kids struggle to understand what manufacturing really is. Although I will say, 15 years, actually I was with Hope at a career fair, for a STEM career fair 15 years ago, I think. And I was asking these high school STEM students what manufacturing was, and not a single kid could define it. And then when I mentioned earlier that I went to my 2nd and 4th grade son's classes to read the books, I asked those kids, so 7, 9, 8, 9-year-olds, and I got way more answers out of them. So that was promising that young kids are starting to understand, and there's so many STEM activities out there, right? So many kids have 3D printers in their rooms, or working with building robots and stuff like that. So I think kids now have a much better understanding, but we try and break it down as simple as possible, and really all you're doing, usually use the phrase, just making something, but I'll define it a little bit more in here, is saying taking something and modifying it to make it something else that someone wants, right? So manufacturing is that simple, and it comes down to how extensive that is, and maybe it's taking raw material, maybe it's taking a component, but you're just taking it and doing something to it. Use the example of breathing, right? Just taking something and moving it from point A to point B is not really manufacturing, right? That's logistics, that's transportation. But when you take oxygen, right? We breathe in oxygen, 2 oxygen atoms make an oxygen molecule, right? We breathe it in because we need it, and then our body does something to it. We spit it back out as carbon dioxide, gets the carbon atom, and then trees take it and use it, right? So it's a silly example, but it kind of shows that's manufacturing, right? You're taking something, you're actually modifying it. It's a chemical reaction. You're actually doing something to it. You're transforming it, not just, again, you might take it and package it. Well, that's kind of manufacturing because you're changing the overall. In fact, med devices packaging is extremely important, not just the device itself. And when I use the word something, again, that's a raw material, components, parts, sub-assembly. So again, every manufacturer is a little bit different in what they're doing with something. And you could have a plating company that's just putting a coating on something, or again, someone else that's actually cutting it, melting it, whatever. So you're basically taking that material or component, and then you're modifying it, doing these manufacturing steps to it. So I know that's pretty common sense, you understand that, but it's just kind of break it down into simple, because I have people ask me all the time, well, how do you define what a manufacturer is, or what a precision manufacturer is? It's really, it comes down to more of a mindset. If you're doing something, you're creating something, you're building something. And so, I'll go through just a few of the raw materials that are used in manufacturing. Again, you get pretty common sense on a lot of these, but steel, you'll see in this picture here, that's what they call bar stock, so that's used in a lot of lathe applications, turning applications, where you're actually doing something more cylindrical, but otherwise the steel can come in big blocks, big rectangular blocks. Of course, aluminum, titanium's used in a lot of med devices, plastics, rubbers, ceramics, so there's a lot of common ones. And obviously there's infinite number more, or variations of these, composites, all kinds of stuff. A couple things, if you want to go into a shop and sound smart, now be careful, because you don't want to lead on that you know too much and then they start asking more questions. But a couple examples if you want to sound cool. If you want to ask a manufacturer machine shop if they use Inconel. It's a nickel chromium based super alloy, if you wanted to recite that. But Inconel is a special material that some shops use, but it's really special and hard to work with. So if you want to sound smart. The other one, on the more the plastic side, if you want to ask them if they use a lot of acrylonitrile butadiene styrene. That's just ABS, which is a really common plastic, but when you know what ABS stands for, it makes it sound really smart. So, in case you want to just throw those out there anytime, go ahead. Just be ready for what they start asking. All right, so on the equipment side, I'll just rattle off a few here. Mills, and this is some of what I covered in the first manufacturing 101 too. You know, milling is using a machine to take away steel, cut away steel. A lathe is similar, but it's in a cylindrical. The part is moving, and so it's cutting with a cutter. Molding machines using a plastic to inject into a steel block. Vertical mill is an example of a mill that cuts at a certain angle, and horizontals from this other angle. Okay, you get the point here. I'm not going to go into a lot of details on equipment today because you can see, I made this so it just keeps spitting things out because there's just infinite number of machines. You're going to see a bunch here today of productivity and be overwhelmed. You're going to go into every shop and be overwhelmed. So I'm not going to go through, in 101, if you want to look back, I do go through some basic manufacturing operations that kind of show the machines. My main point in this is, don't try and learn too much on machines and try and go in and be an expert. I guarantee every shop you go in, you're going to see new machines that you don't recognize, and even experts in the industry. So when I took over my role as MPMA, I had a decent amount of experience, but shoot, there's a lot of shops I go in where I don't even know what this equipment is, and I feel like an idiot. So I went to one of my most experienced machinists I work with. I'm like, hey, Aaron, can you just go through? I'm like, I had all these questions. I felt like an idiot. I'm like, can you tell me what this machine is, what this is? And half of them is like, I don't know what that is. I've never heard of that. I've never seen that before. Like, okay, he's got 30-something years of experience, and he's a brilliant guy, and he doesn't know what this stuff is. So my main point is, when you go into shops, be a sponge, right? Just ask questions. Don't be shy. Whether you work in a shop and you want to ask shop employees or you're visiting a shop, people love to talk about their technology, especially, they love to talk about parts, but they really love to talk about technology. And, yeah, we got this machine that can do this, and it integrates this, and can automate this. So I would encourage you to just put your humility cap on and just say, what's that machine there? And they might say, oh, that's just a mill. Oh, okay. I mean, it might be something you're familiar with, but you just haven't seen that one or that brand or whatever. So again, I could go on for hours about all the different technology and equipment stuff, but you would just be overloaded. You would still go into a shop and be like, okay, that doesn't look like the machine that Steve had up on the screen, and so now I don't know what, So I would just encourage you to ask questions, learn, and just, and you'll still never absorb it all, but it's just, again, that'll be what the person you're visiting loves to share about and love that conversation. So, all right, I'm going to move on to quality now. So we go through some terminology here. So the quality management system we already talked about, but again, it goes over your policies, your procedures, your regulatory requirements, your standards for day-to-day inspection. So have you guys heard of the terms quality assurance versus quality control? Never wondered what the difference is or why some people use one or some people use the other? This is one of those things where I'll say there is no exact right answer. There's a general concept of what the difference is, but people use them interchangeably all the time. So, oh, I gotta go to my QC lab. Well, I work for QA. You'll hear those all the time. So there's really no right or wrong answer, but in general, quality assurance is more on the preventive side. So you're assuring that the quality is gonna be good, right? So you're proactively coming up with processes and more systems and things around the process to make sure that the product's gonna be made right. Whereas quality control, as you can imagine, the control word is a little bit more responsive. So they're both equally important, right? You can't just put it in policies and procedures and say, okay, we're good, we're gonna make 100% good product. You still have to check it, right? So they both go hand in hand. A lot of times it just comes down to whatever the company decides to put on their title on their door or the person's title or whatever. But they're both part of the whole process. Inspection, so this is more on the quality control. So inspection, obviously you can imagine it's just checking parts. But there's a lot of different ways to check parts, and I'll go through some of the terminology here that, again, will help you understand. You'll hear these words and a lot of acronyms that people aren't going to explain to you unless you ask. But just inspection's done anywhere in the shop, right? Some companies have different philosophies on whether they want to do it at the work center, so you might have a machinist at that work cell inspecting the parts as they come off the machine. Or they put them onto a cart, or a person comes over and puts them on a cart and they bring them to their quality lab and do it there with designated quality personnel. Most shops have a combination of the two, right? They're gonna have some in-process inspection done at the work cell and then some done in the lab. Obviously, it's a little more timely to do it on the spot. The person who's running the machine maybe can respond, quicker and be able to say, okay, I'm off by a couple 10 thousandths. I'm going to make an adjustment on the machine. So that comes down to, oftentimes smaller companies will do more at the machine with their shop personnel. Larger companies will have more designated staff to do quality inspection and take the product away. Plus, it's equipment, right? You're not going to have some of the main inspection equipment sitting at the mill. Sometimes they do, but those are expensive pieces of equipment, take up a lot of space, so a lot of times they can't do that. Control plans. I mentioned like bill of materials before. Control plans are kind of similar. Control plans are basically saying what's going to go into the inspection process. So the control plan will show you what the designated steps are for the inspection process, what tools to use, what the frequency is, all that, and I'll talk about some of those terms here. But that is basically the guiding plan, kind of the map for the inspection process. First off parts. So when parts come off of the machine, oftentimes that's when you're going to do your first inspection, of course. The AQL is what's going to, the acceptance quality limit is what's going to determine the frequency you're going to inspect those parts. So usually you get a first part off the machine, you're going to inspect it to the control plan, right? And sometimes it's more or less extensive, but that AQL is going to say, okay, once the parts come off, am I going to inspect those parts every hour, every fourth hour, every 1,000 parts, it's going to determine how often you're checking those parts. And then when you're first off, the first time you're producing something, you're going to do a different inspection than what you'll do once you're in production months or years later, right? So you might have heard this term before, and again, this is where people use different terms a little bit. Same basic acronym, that they might just keep the I in there or not, but it's first article report or first article inspection report. So that's the only difference between those two acronyms. But basically a first article inspection is where you're going to take a new part, generally a new part, or it might be after you've made a modification or something, but you're going to do a full in-depth inspection of it. So if a part print has 40 dimensions on it, you're going to inspect 40 dimensions. If it's got 80 dimensions on it, you're going to inspect 80 dimensions. So first article inspection is going to be everything across that part print. That's going to tell you exactly how to check it and what the range is you have to pass or fail within. So first articles can be really simple, but they can be really extensive and take many hours. So this isn't going to be something that you do every time you're starting, every time you're checking parts, because it could take 20 hours to do a first article inspection. So they're pretty extensive. CPK then is another word. I don't think it stands for it. It's a statistical symbol, I guess. I mean, C generally, officially, I don't know if it's official or not, but it stands for capability otherwise. But basically what you're trying to do is understand how capable a process is. So the first article is checking everything on the print, but you're checking generally one or maybe two or maybe three parts. The capability, a CPK study, is going to study the variability over a group of parts. So a CPK study you might do on 30 is a pretty common number, you might do it on 60, whatever, you're going to do it on a larger number of parts. And this gets into all the statistical analysis, which I won't get into today. But it allows you to say, okay, over the course of 30 parts, we're seeing this much variation, this one feature. In a CPK study, you're not going to do across every dimension on the first article. So if your part is 40 dimensions on a CPK, you might do it on 4, 5, or 6 dimensions. The critical dimensions, right? So, and you're going to look to see how much variation there is. And what that does is help you understand what your frequency and what your inspection plan needs to be going forward. So again, this is new parts, right? So again, you're not doing this day in and day out. The CPK allows you to say, okay, on this part that we're producing, this dimension varies by, this amount. And you're going to look at, so we're looking for in statistics, the variation. And if it varies very little, then you can loosen your controls, right? If it's staying locked in all the time, never changes, and you've got statistical analysis to say that, you can say, okay, we're just going to check it once every run, or once every 3 days, whatever it might be. Versus, there could be some things that do vary a lot, and it could be because of human interaction where something can vary more. It could be temperatures changing, something that's very sensitive. So that larger variation in the CPK study is going to tell you need to inspect this more often. So I might need to inspect it every single hour, or I may need to inspect 100%. And so that's going to be determined between the manufacturer and the customer to determine what that PPK requirement is and how tight the variation needs to be. One thing I didn't cover in this, I should have, you may never come across this, but the FMEA, if anyone's heard of that before, but it's the failure modes and effects analysis. People refer to it as FEMA, not the FEMA you might know. But that's where people, again, between the manufacturer and the customer, they'll go through a whole process, FEMA, of identifying what are the risks involved in manufacturing and the level of risk, right? So the occurrence of something, you might, again, based on the variation, you might say, this is likely gonna happen. So that's a concern, right? But what's the risk? If it's a part that's, whatever, the shoe, the things on the bathroom doors, you use your shoe to open up, right? Well, if something fails on that, what's the worst that's gonna happen? Somebody can't use the bathroom in a timely manner. I guess that could be bad. But if it's a med device that's controlling, your pacemaker for your heart, and that fails, well, now suddenly the risk is higher, right? So that's a whole analysis that companies go through, is figure out, okay, what's the likelihood of this problem, and what's the risk involved in the problem, and then what are we going to do to mitigate that, right? Are we going to inspect it more often? Are we going to put different controls in place? Are we going to automate something versus manual? So that's all that. Again, it's all that statistical analysis. There's tons of data, and I would tell you, especially med device, aerospace, defense, all of them are getting challenging now, but I mean, we had one part for a validation where we go through all this kind of stuff, and we have a 200-page report for one part, and we have something that might have a 12-part package that all goes into an assembly or something. So it's insane, just thousands of pages and thousands of hours of compiling all this data and measuring, and it's crazy. And I'll talk about that a little bit when we get to the lean section too. So SBC, anyone ever heard of that phrase? So this is kind of relates to what I was just talking about, but SBC is statistical process control. So really, that's a way to kind of mitigate that risk, right? So SBC is really watching that data from a statistical standpoint and understanding throughout the day, watching it live and knowing how things are fluctuating. And actually, there's a lot of cool things that with technology now where you can have built into the machine to say, okay, when you start to see this variation, the machine will adjust itself. So lots of cool stuff at SBC that, again, it's usually bigger companies, higher volume production. You're not going to do that on one-off, making 10 of something. This is going to be more if you're making millions or tens of millions of parts and you want to really understand where things are running. But again, as you guys know, especially in the last few years with AI, and but even before that with a lot of just data analysis, you've got machine shop owners sitting at home or sitting on the beach somewhere looking at their cell phone and looking at exactly how their machines are running, their quality, their cycle times, their variability, all that good stuff. So that's what all that data does. So it's really cool if you like it, and it's really comforting if you just want to know that it's there and not have to think about it. Some tools, you guys might have seen these, and again, these are some basics. If you're going into a manufacturer, you should probably kind of know, but micrometer, that picture is a very common tool. These are the basics of inspection. People are using all day, every day. They've been using them for 70 years, more than that, I don't know. But it's still the same tools you use today. Caliper. So a micrometer is going to be a little bit more fine-tuned, very, checking the width of something. It needs to be pretty tight tolerance. Calipers, you can do a little maybe lesser tight tolerance, but still kind of checking the width or length of something. Gauge pins, used all the time for checking inside diameters of things. You got a hole, and you need to make sure that hole's concentric or that it's whatever the right size. Use gauge pins. CMM, this is where there's again tons of other inspection equipment, but this is the stuff you see all day, every day in manufacturing facilities. 20 years ago, you saw CMMs, but you'd see them more in high-end, high-volume facilities. Now you go into that 10-person manufacturer who does contract manufacturing, making one-off stuff, and they still have a CMM. So you will see CMMs everywhere. And they might look a little different, but in general, that looks like what you're going to see in an inspection lab. This is the lower right picture. A CMM is basically just, coordinate measuring machine. Is basically just an automated inspection. So when I mentioned first articles before, generally a person sitting and doing a first article would use these hand tools and check things one by one because you're just doing one-off. But if you have something where you're going to do a first article every week, whatever, and it takes 40 hours to do it, you're going to program all that into a CMM to say, okay, you're going to use this probe to touch down here, touch here, touch here. And what an operator could have done in 40 hours and checking everything to do one part, you could use a CMM to check 10 times as many data points in a tenth of the time, less even. I mean, it could just do one part in literally minutes that took somebody 40 hours to do. But you also took a bunch of hours to program that CMM with a high-paid, high-skilled person. So it's a balancing act, right? If you're doing it once, you're going to probably do it manually, and if you're doing it every week and it takes all those hours, you're going to use the CMM. So again, this is stuff that you'll see in every manufacturing shop. Pretty. Tolerance. So this is a really fun part. This is where I mentioned earlier. People ask, "What do I mean? What do we mean when we say precision and MPMA or the Minnesota Precision Manufacturing Association? What does that mean?" Again, I'm not going to define that. It's more of a mentality of tight tolerances, regulatory stuff, things that are intricate and challenging. I always use the example of, okay, this table, would we call that precision manufacturing? Probably not. It's you're making a table if it's off half an inch or something, it might not even matter. But what if this table was made out of stainless steel or some other composite material that was going in a space station, and if it was off, you just transported it across the universe, and now it won't fit in there, and you got a bunch of people spending billions of dollars a day, and now this is off and it won't fit. Okay, well now maybe that needs to be precision, right? And holding it to a tolerance, this whole length to a super tight tolerance is precision, right? So there's no exact definition, but tolerance is a key part of that, is understanding what fluctuation and how tight something needs to be. So I'll give you a couple examples here. So if you're cutting a 2x4 for your home project, you might hold it to a 1/16 of an inch, which most of us probably don't, right? I know I didn't. But 1/16, you're looking at a tape measure, and 1/16 of an inch is, maybe you can see the 1/32. I can't see those anymore hardly. But 1/16 is usually a pretty tight tolerance on cutting a board, or something for your siding on your house or things like that. That would be pretty darn tight, right? And that's about 6/100ths of an inch, or 0.0625. Standard precision part manufacturing would be usually about plus or minus 5/1000ths. So 0.005, so less than a tenth of what you're cutting that 2x4 to, right? So it's pretty small. You can't hardly see that. It's a tenth of what, that's less than the 1/32 on the tape measure, which you can barely see. A human hair is about 3,000. So if you pluck a hair off your head right now, look on the end of it and see that diameter, you don't have to do it. If you look on the end of that diameter, that's about 3,000, right? So again, that's tighter than the tolerance most manufacturers are holding on precision parts. And you take the diameter of your hair, you can barely see it, feel it, measure it, whatever. Now, I said standard precision. When you go into shops, they're really, again, working on aerospace stuff, real high-end stuff. Again, that space station part that has to be right, or it's going to cost tens of millions of dollars, or it's going to kill someone. We start getting into really tight tolerances. So a high precision part might be plus or minus 1/10,000th of an inch. So take that hair off your head and cut it. And I don't mean cut the length, I mean cut the diameter of it 30 times. It's nothing, right? It's literally, you can't see it. And they're holding tolerances to that. On the length of something, the flatness of something, the concentricity of something. That's just insane. The other thing you might hear is, instead of saying 1/10,000ths, they might say 1/10ths. They'll say tenths. That's just a different way of saying it, so it's kind of hard to there's tens, tenths, 10,000ths, or all these things that sound alike, but either way, you're getting into nothing, right? You can't see that. Part of the challenge is, how do you measure that, right? So there's definitely equipment that can measure that, but what if the temperature in the room is wrong or it fluctuates that day? Then even that inspection equipment is capable, it still might not be able to measure that. Or the surface of something, right? So this is easy, it's a flat surface, right? What if you've got a contour? I saw that show the titanium, hip transplant or whatever, bone replacement. You got a curved surface, right? Well, holding that to tenths, how do you measure a curved, ever-changing surface? So then you get in a lot more inspection equipment that can do imaging, right? So that's actually taking an image and then comparing that to a database and understanding how they overlap. Again, that's not human, that's not a person measuring it, it's the computer analyzing it. Really cool stuff. You probably should see some of that on the tour today. But a lot of shops are using equipment like that. Now you'll see like white light scanning equipment. Kiosk is a big name for that. You'll see that in a lot of shops. But those machines will have more of a scanning system that'll compare the databases. Really cool stuff. All right, so now I'm going to be, how am I doing on time, Cindy? I think we're good, right?
Yeah.
Okay, lean is a super fun one. You guys have no doubt seen some of this, and the fun thing about lean, I get really excited about this, and my wife probably gets drive her nuts, but lean is something we get to use at our home, and I'll show a couple examples. Like lean is something we use in daily life, or we should use in daily life, or we try to use in daily life. And most manufacturers have implemented some level of lean or continuous improvement, they might call it. So this is stuff that you might not readily see, but once you start seeing some of the examples, you'll start to realize, oh, you see it throughout different people's shops. Some are really, adhere to it and have a great culture of lean and continuous improvement. Some will dabble in it and they'll try something and you'll see how, the leftovers of it, and you'll see you probably have done it at home too, where you try some of these things and they don't end up panning out. But it's really fun. Just the company I work for, we decided 15 years ago to kind of implement a continuous improvement program, and we really wanted it to be a cultural shift with our company. So we really embodied it. We really drove it. We had competitions. We had fun with it. We tried to get every employee engaged. We had, and we had literally thousands of continuous improvements over time for a 120-person company. So almost every single person was involved in it. It did change the culture of our company. And you walk through that shop today, and it'll look like productivity, where you can eat off the floor and things are organized. And that's the kind of stuff that, to look like that, to live like that, you're embodying lean, whether you even call it lean or not. It's the way, kind of the way they live. So as I was just kind of saying, lean is a philosophy of manufacturing to reduce waste, improve efficiency, and save money. So it's just good business practice, right? I mean, it's pretty common sense stuff, but you guys have probably all been through shops that do not embody lean, that you would not want to work in, you would not want to eat off the floor in, and I wouldn't want my kids working in, and that's just reality, right? So when we're trying to influence kids and get them more interested in manufacturing, you might be making the coolest products, using the most high-end technology, but if you're working in some dingy shop that's got clutter all over the place and it's dirty and it's just doesn't feel good and it's not well lit, like, I don't want to be there, right? You're not going to attract young people to go work at those companies. So it's something that we struggle with when I'm talking to shops, even when Cindy's trying to coordinate a tour, like, it's a great company and great people. They've got great people. We can't host a program there because we can't portray that as the image of our industry. Even though it's a great company, we've got to show places like productivity, or name another 10 companies in the Twin Cities that are just pristine, beautiful floors. That's what we have to start portraying, so that young people who are comparing that to working in Starbucks. Obviously not a connection at all, right? But in Starbucks, it's clean, it's comfortable, it's organized, whatever. I feel comfortable there. Versus going into this warehouse-looking factory, whatever. So we really have to break down those barriers, so especially young people who don't even understand manufacturing and start to realize. I mean, I've had a few family members in the hospital in the last year, so I've been visiting them and seeing different practices there. And like, I could name at least 6 companies in the Twin Cities that I would rather have a surgery in than most of those hospitals. And nothing wrong with hospitals. It's just again, it's policies and procedures and adhering to things and keeping it clean. It's like, it's not quite as good as some of these manufacturing facilities. You guys, if you're familiar with lean, you've probably heard Toyota was a big player in kind of getting the lean movement going. It's just, again, that's been their culture for many, many years, especially mainly since the 80s, before that even, but they really drove a lot of what we consider as the lean practices today. So Six Sigma, I'll just touch on real quick, but basically it's a philosophy of zero defects. So you've probably heard of Six Sigma green belt, Six Sigma black belts, but it's more, a lot of times it's more engineering people, and they're more focused on how do you again control processes. It's embodying a lot of lean principles and the quality principles, and really figuring out how to drive towards no defects theoretically, right? So you're driving that down to, that's why Six Sigma, if you're familiar with statistics, basically means like nothing, right? Six Sigma is done with like almost nothing, no likelihood of a defect. So I'm gonna go through some other lean related terminology here. They're kind of fun ones. So Kanban, and a lot of these words are Japanese words. So Kanban, we talked about inventory stuff before, but really Kanban is a system, usually an agreed upon process between the customer and the manufacturer. So rather than, here's a purchase order, make me 10,000 parts. A month later, here's a purchase order, give me 10,000 parts. Here's a purchase, and so on. Kanban really allows for a more real-time, more steady flow of product, and so a Kanban usually have an agreement that'll kind of go along with the purchase order. The purchase order might just say, we're ordering 1 million parts over the course of this year based on our Kanban agreement. And the Kanban agreement will actually stipulate, we're going to take 3,000 parts at a time, and you have to maintain this much in inventory, and we want to be able to get them within 2 days whenever we order them. you're gonna agree to have 3 lots of 3,000 available so that they're ready to go at any time, whatever. So it's all those details that go into making sure that the manufacturer has an inventory that's ready to go, and that the purchasing company, the 3M or the Boeing or whoever's ordering the parts knows that they can get that product. So the theory is that it makes us more lean, right? So rather than batches of 10,000 that just take up a lot of space and a lot of, and a lot of cash flow and everything, if we can do them into smaller bite-sized pieces, it allows the manufacturer to manufacture them at the timeline they prefer. You know what, we're gonna actually build 12,000 at a time because it's more efficient, or actually it's easier for us to do small batches and get them through it, whatever. It allows you to be more efficient and have less inventory theoretically, and have a steady flow. Now, when you go back to like COVID and then and the supply chain stuff, Kanban's got so messed up. I mean, I know I talked to companies who said basically their customers just shut them down for 6 months because they didn't pay attention to the adjustments of their Kanban, and so they just kept taking product because of forecasts that set it up and certain things. Well, as you can imagine, during 2020 to 21, 22, forecasts were worthless, right? Like, who knew what was going to happen? So that's a caution with Kanbans, is that yes, they're supposed to keep us more lean, but only if the forecasts are right and that we maintain a nice steady flow. FIFO, anyone heard of FIFO? First in, first out. Use it in a lot of accounting practices too. So first in, first out. You can imagine again a home application is when your kids, you got the half open box of Cheerios. It's it's mostly gone, and then you buy the new one to replace it, and they open the new one, right? Now the old one's getting stale, or the milk in your fridge or whatever, and now we got to throw away food because they opened the new one before they finished the last one. You can tell me I have this conversation daily, and I do not like to waste food, so this is one that drives me nuts. But first in, first out is just the concept of, okay, if I bought this box of Cheerios in March, let's go back and say this bought them in December, and then I bought a new one in January, I gotta use the December ones first, right? Common sense, pretty common principle. But applying that in manufacturing, where you don't just have 2 boxes of cereal with an expiration date printed on, and if I've got 15 orders of something, I just mentioned Kanban, I might have 15 orders of something, and they were produced over 6 months, and now the customer just called and said they need parts right away. Like, oh, I got this batch sitting right here, I'll just get it out to them. Well, it's not good for a lot of reasons, whether it's for shelf life of something or just understanding and processing and that variation too over time. You want to have a nice steady flow and have things go in the same order that they came in, or the reverse order, I guess. But so first in, first out is a principle most manufacturers should adhere to. They don't always. Again, this is a little bit more of a higher volume product that's a little bit more critical. But that's key, is to make sure you're using your oldest stuff first. For obviously, again, those of you in accounting know inventory management is such a huge challenge for manufacturing companies. A lot of it's just human error, right? People just putting something in the wrong spot, grabbing the wrong thing, not entering in the right information. Inventory management is just, it's a challenge. Gemba, anyone ever heard that word before? I love this one. There's another Japanese word. Gemba basically, I say the phrase before I'm saying what Gemba is, but in lean you'll hear a lot, get out to the Gemba. And it's such a strong principle, and it's so important to manufacturing, and it's so important to any of you who are not manufacturing, because what it means really is go to the place, and see it live. So you could sit in a meeting and have someone tell you about what they do for business, but you want to see it, right? You want to see it live. And in lean, when you're trying to solve something, when you're trying to improve something, you gotta go see it in action, right? So when people have meetings in a room like this, and they sit there at charts and looking at screens and pictures and whatever and trying to solve problems, what oftentimes happens is they're missing the most obvious things, or they're missing the input from certain people. And a lot of times what happens is you go out to the shop and say, okay, let's go out to that work cell and actually stand there and actually map it out and talk through it. And then Joe walks by and says, oh yeah, I see that all the time, here's what's going on. And the person who knows the best, because they just didn't get invited to that meeting in the office, wouldn't have contributed. So that's a concept that in lean, it's always, go see it in action, go experience it, go touch it, go feel it, go watch it, and no different than when you're just trying to learn about manufacturing. Go see it, right? So don't just watch a video, don't just sit in the conference room and have a conversation. For most of you, if you're going to visit a manufacturing company or going to go take a tour, but that's just a really important concept in lean. 7 ways. This is where it gets into really fun stuff in lean. And it's all the stuff you would do at home too, so it's really cool stuff. Well, this one's a little bit more manufacturing related, but 7 ways. I'll go through them pretty quickly here, but ask questions if you have good questions. Defects is a pretty obvious one. Obviously, if you produce something that's bad, that doesn't meet print, that's got a blemish on it, whatever it is, that's a waste, right? You just produce something that has to get thrown away or fixed. Motion. So, if you've ever, well, in manufacturing and lean, they use the spaghetti diagram a lot. So, if I have to produce something and I do step A here, and then I do step B over here, and then I do step C over here, and D over there, nobody's paying for that motion, right? A customer doesn't want to pay for that time, or it could be across the whole building, right? So motion is a waste. It may be necessary, but these are all things that we all should be questioning in lean and manufacturing, is to say, is it really necessary? Do I really need to move from A to B to C to D? Could I move the 2 machines closer together? Could I, whatever, at least do it in batches where I do 10 of something before I move. That way I'm doing theoretically a 10th of the motion, right? So motion is a waste, and how can we avoid it? Spaghetti diagrams I reference is basically track it. Literally, you just, on paper, just move from A to B to C to D, and you watch, and sometimes you'll literally watch someone so you track them, and you see it looks like spaghetti because they go all over the shop 10 different times, and it's just a lot of movement, right? Waiting. So obviously, if every time I need to produce this, I need to sit and wait for Grant to get me the next part, I'm sitting here waiting, right? I'm not producing anything, I'm not adding value to anything, so waiting is another waste. And I'll say all of these are things that the way I always look at it is the value add, right? So when I mentioned earlier what manufacturing is, it's doing something to transform something, right? So these are all things that are not, at least not successfully transforming something. So does a customer want to pay for something that's not being successfully transformed? No. So it's always that in mind, keep that in mind, is okay, because someone will say, well, I have to wait for this because I always got to wait for Grant. And employees will get defensive over it, like you're offending them, like, well, why are you walking all around? Well, I need to get this done, and they'll get frustrated because you're challenging. It's like, well, no, do you really enjoy walking around? Which, that's another concept, another idea with the 7 ways too, is, well, maybe that person actually does like walking around. Because if they had to sit here all day and just do this and never move, like that's kind of defeating too. So maybe walking around allows them to socialize it, or not, just to smile at people and walk by and makes them feel it and get their steps into the day. Okay, well maybe there's something else we can do to get your steps in that's not affecting the process time. That's just something to keep in mind. Overproduction. So as some of you know in the banking or accounting fields, is overproducing something, having extra inventory, which a lot of people in the shop floor think that's a good thing, right? Like, oh, I made 10,000. You only asked for 8,000, but I made 10,000. That's great. Okay. Then the accountants are sitting there saying, well, okay, all that cash is tied up in the raw materials, and now we got inventory sitting there and labor, all that. So overproduction is a waste. Now again, it can be a conscious waste. We can say, you know what, actually, because it's going to reduce our setup time, and we're going to be more efficient by overproducing. You can choose to do that, but at least understanding it, because otherwise that part sitting on inventory, as probably some of you know, someday that customer will call back and say, oh, we're making a design change, so any forward orders going forward are going to have this feature. Oops, that overproduction now is garbage because they didn't pay us to do it. That wasn't on the purchase order. They're not obligated to take it. Now we got to throw all that away. Over-engineering. This is one that people really struggle with the most, probably because it feels good, right? So I mentioned before that a part print might have 40 dimensions on it, and they might have tolerances of plus or minus 1/10,000th. But again, if somebody said the tolerance on this needs to be 1/10,000th, you'd say, no, it doesn't. Why would you ever do that? But there's some engineers out there, especially young engineers, that are overzealous and they want to show what they can do on a part print, and they'll overdo it. And what does it cost to make this table to 1/10,000th versus plus or minus 20,000th? It'll quadruple the price. So in the end, that's a waste, because did the customer need it? Did you need this table to be that? No. Are you willing to pay quadruple to get it that tight? No. So that's a waste. And that happens all the time, especially on part prints. That's where you'll see it the most, is people put on things and say, I want it to be this, I want it to be gold plated, polished shine, and all those. I mean, they literally will do surface finish that's too good. They'll do tolerances that are too tight. And that costs money and time. Transportation. So it's similar to motion, of course, but motion is people, transportation is logistics, right? So again, if I've got plant A and plant B and I have to have a truck going back and forth, there's no value to that. I might need to, but it's not necessarily value. And inventory. So again, this relates to overproduction, but inventory sitting on the shelf, again, it may be necessary, but it doesn't provide value. It's just sitting there, it's collecting dust, it's risk, it's cash sitting there. So that's another waste. 5S, this is the one where it's more visible. I'll probably be wrapped up in a few minutes, so I told them that should be good. 5S is the fun stuff, and this is the stuff that, again, you guys probably live at home or try to or aspire to. But you know, if you imagine your spring cleaning, and some of us, this might be what a garage looks like. I hate to say sometimes mine does look like this. But you know, you do spring cleaning, you clean up all this mess, and then what happens 6 months later is it back to being this, right? So 5S is really just about trying to figure out how to keep that, you know, that clean, workable environment more part of your daily process. So making your garage look like this, right? So the 5 S's are sort, which is basically going through all your junk and deciding what goes to Goodwill, what's going to get thrown away, what's going whatever, storage, whatever. Set in order is to just put it where it belongs, right? So I'm going to decide, well, I'm going to put these totes over here, I'm going to put these tools over here, I'm going to, you know, identify where everything's going to go, right? Shine, cleaning, right? So you're literally cleaning everything, you might repaint it, you're making it all look nice. So these are the common sense ones, right? Like you're cleaning things up, this is what everybody does. Everybody gets through sort, set in order, shine, because then you make your garage look like this, maybe. Standardize, this is where it gets a lot more complicated, a lot more challenging. So now is where you start saying, okay, I'm gonna keep all my winter stuff over here. I'm going to color code things that I know, you know, these type of things are gonna go in this tote. You're kind of creating standards that kind of help you understand where things belong, help communicate that, so when someone else goes in your garage, you can see things. And standardize, and the next one, sustain, kind of go hand in hand, because like this is a great example, what they call it a shadow board. So standardizing it is to say, the needle nose pliers always go here, that's standardizing, right? But if you don't do something that's gonna make it clear and easily repeatable, what happens is, you know, stretch wrap, it's not there, right? So people don't adhere to it. If you're not clear and concise and easy, people will just stop doing things. So standardizing is super important, you have to do it, but what's even more important is sustain, and this is what everyone struggles the most with, right? When your kids understand it and you've gone through everything with it, you've standardized everything, color-coded everything, and your kids still don't do it. Ugh. So part of sustaining is understanding the mental concept of it too, of like, how do I get my kids to start listening? How do I get them to understand what I'm doing? Can anyone tell me what's missing up there right now?
Stretch wrap.
Stretch wrap, right? You can immediately know it. Do you know that person's garage or work or manufacturing facility? No, you don't know what they use, but immediately you can see something's missing. So creating visual standards, again, color coding things, setting the expectation, involving employees in this process too, or involving your kids in this process, helps, because then they're more likely to sustain it, right? If your kid gets involved and helps you with it and does all the making the shadow board and stuff, probably more likely to sustain it. Not a guarantee, but so 5S is like just a standard part of lean and shop, and you'll see when you walk through shops, you'll see this kind of stuff. Look for it next time, and then you can comment on and say, looks like you got a great lean program here. You got stuff 5S, and looks like you've identified your 7 waste over. We used to have a wall that was called the wall of doomed profits, and it was where we put our scrap. That's where we staged our scrap before we worked on it or worked that needed extra work. And we wanted to instill that mentality that this isn't just scrap parts, it's profitability, it's your profit sharing at the end of the year, it's your pay increases. If we can reduce that, we can do more for you. So it's making sure everybody understands it and they're part of it and can appreciate what you're trying to accomplish. 5 whys, who knows what the Socratic method is, right? This is kind of Lean's version of Socratic method. It's just asking questions, right? So when you're trying to solve something, and it sounds a little annoying, say, well, just keep asking why. But that is kind of the premise of it is, okay, we had a scrap part. Why? Well, because somebody turned it wrong. Well, why? Well, because, it was Sue and she's new and she wasn't trained really well. Well, why? Well, because we don't really have good work instructions. Why? Well, because we don't really have someone designated to create. You know, you start to dive in like, oh, we need to designate someone to write our standard work instructions so that training gets better. Like, it's a common sense thing, but it just gets you to dive deeper than just say, why? Well, Sue screwed it up. Okay, well, take Sue out back and, give her official warning, whatever. Don't. All right, I think that's it. Cindy gave me a 2-minute warning and I'm wrapped up. So, I know I went through a bunch of stuff, and I went through very little stuff in the scheme of things, but I just wanted to throw a bunch of stuff at you, some new words, some new concepts, things that you can, again, take your own shop floor, take the customer's shop floor, ask questions of them, learn more, have a little better understanding of what they're dealing with. What questions do you guys have? Anything that I totally didn't cover today you want to ask a question about? Anything that didn't make sense? Most of them did a really good job. All right, well, if you guys don't have any questions, then feel free, well, you got like Cindy's contact information, and most of you probably have mine too, but feel free to reach out anytime if you guys have things you want to ask questions about. Again, I'm not necessarily the expert. A member asked just last week about some very specific stuff about some regulatory stuff. I'm like, shoot, I don't really know the answers. So beautiful thing about MPMA is that we've got resources. Not, not official MPMA resources, they're just industry partners that members of MPMA that would say, oh, you can go talk to OECS about this, or talk to MinTap about this, or talk to productivity about this. And really cool to have all these people around MPMA that are the experts, because that's what makes MPMA special. So I would encourage you to reach out. Obviously, when you're in shops, ask lots of questions, explore, learn, and don't hesitate to reach out if you want to try and find some of the resources. Of course, keep coming to the Toolbox talks. So, all right. All right, well, if you guys don't have anything else, thank you very much. So, hope you got a way to coordinate, or what do you want to do for tours?